Properties of kites and trapezoids, section 6.6. So finishing up our chapter on parallelograms and quadrilaterals, we're going to talk about what a kite and trapezoid is. Neither one of these are parallelograms, by the way, but they are kind of unique quadrilaterals in themselves. Section 6.6. The first one we're going to talk about is a kite. A kite is a quadrilateral with exactly two pairs of congruent consecutive sides. Who can tell me what consecutive means? In a row. Okay? Like right here. Those are two congruent consecutive sides. They're next to each other. And then those are two more congruent consecutive sides. They are sides that are congruent, but they're also sides that are next to each other. Congruent consecutive sides. All right? If a quadrilateral is a kite, such as FGHJ, then it has the following properties. The diagonals are perpendicular. That is an important one to remember. The diagonals are perpendicular. What's it mean to be perpendicular, Tom? Yeah, if you look right there, they're intersecting to form 90-degree angles. So all four of those angles would be 90 degrees. That's important. And then the other part is exactly one pair of opposite angles is congruent. So exactly one pair of opposite angles is congruent. So if you look here, G and J, those are congruent angles. All right. Are F and H ever going to be congruent? No, not necessarily. Okay, no, they won't be. There is something, technically, in a sense, like if you have a square, I guess, right? This is something, they don't have it on here, but this is a special property to note. The diagonal, okay? The diagonal that runs kind of a cross. So for example, this diagonal, and it's only this diagonal right there, that red diagonal, that is an angle bisector for both those angles, actually. Okay? Which makes sense because the two triangles are congruent, right? So if the two triangles are congruent, the angles have to be congruent. Well, then that means the line's an angle bisector. It kind of makes sense if you think about it in the end. But that is something that's very important. That line and that line only is an angle bisector. Okay? This line right here, not an angle bisector. Understand that. Two differences. Not an angle bisector is an angle bisector. Okay. After kites, we have trapezoid. The trapezoid is a quadrilateral with exactly one pair of parallel sides. No more, no less. It has one pair of parallel sides. Okay, exactly one pair of parallel sides. If the legs of a trapezoid are congruent, the trapezoid is what's called an isosceles trapezoid. All right? If the legs of a trapezoid are congruent, the trapezoid is what's called an isosceles trapezoid. So if those legs right there are congruent, then it's an isosceles trapezoid. Each side is parallel. So if I think about this here, if I look at these two angles right here, what type of angles are those? Who remembers from parallel lines? What type of angles are those two? Same side interior angles. Same side interior angles always add up to 180. That is important to note. The same is true on the other way. So on trapezoids, you can always find the other angle by subtracting from 180, essentially. Okay, that's important. Now, isosceles trapezoid theorems, these are special ones. In an isosceles trapezoid, each pair of base angles is congruent. Okay, so each pair, so that means these would be congruent and those would be congruent. That's only true for isosceles trapezoids. Isosceles meaning two sides the same. If a trapezoid has one pair of congruent base angles, then it's isosceles, just kind of in reverse. And then a trapezoid is isosceles if and only if its diagonals are congruent. That is important. So if I draw a diagonal across here, in isosceles triangles, those are the exact same. Okay, the diagonals are going to be the exact same. Important to note. So if you look at this kite here, a lot going on. In kite ABCD, I want to find the measure of angle BCD is 98 degrees. Okay. So BCD is 98 degrees. Angle ADE is 47 degrees. ADE is 47 degrees. Okay. I want to find each of the following measures. I want to find angle DAE. So I want to find the purple angle there. I want to find angle BCE. BCE. Find that angle right there. And then I want to find, let's use orange, angle ABC. So I want to find this angle right here. All right. So if you look at this here, a lot of you see we have a shape of a kite, right? But what's that kite cut up into? 4 different what? And actually, it's not 4. There's actually 1, 2, 3, 4. There's multiples, like 8 different triangles there. If you kind of combine them all. Does everybody see that?
Yeah.
All the different triangles going on? What's important about triangles? Triangles, the angles add up to? 180. So if I were to look right here in the middle, what do I know all of these angles will be? Right here. How many is each one of those angles going to be? 90. Why? Because those lines are perpendicular. So there's 90 degrees, there's 90 degrees, there's 90 degrees, there's 90 degrees. Does everybody see that? 90 degrees all the way around. Which angle do you see? Oh, I can find this angle right now. Which angle do you think you can find? I can find DAE. I can find this angle right here. How can I find that? What do I have here? A? Triangle. What's this degrees?
90.
What's this?
47.
Can I find this angle?
Yeah.
What would I have to do?
It'd be 40.
Subtract from 180. So I would go 180 minus 90 minus 47. And I get angle DAE has to be 43 degrees. Okay. DAE is 43 degrees. Awesome. Next one here. Let's find, I'm going to find ABC next. I feel like that one's probably the next easiest here.
Oh, that one's really easy.
ABC is?
No, BC.
BCE is easy.
Yeah.
Do you see a BC? I don't know. It's not half. It's not half. This angle right here is 47 degrees, right? What's the angle right next to it going to be? That one's 47. Okay, remember that's an angle bisector. So if this one's 47, this one has to be 47. If this angle is 98, can I find this small angle up here? Yeah, what would I do? I would subtract, so I would go 180 minus 47 minus 98. And that gets me what then? What does that get me, Max? What? 35? Right? Is that right? So I get 35. Is that my answer? No, because that just gets me half that angle. How do I find the full angle then? I have to take it times 2. Take that times 2, meaning ABC is going to be 70 degrees. Angle bisector. So if this is 47, that's 47. If this is 35, this is 35. Okay? What type of triangle do I have right here? If this is 35, what's this? Can I find this green angle right here then? You bet. I can find BCE then. I would do 180 minus 90 minus 35. And BCE has to come out and be how many degrees, Jack? 55 degrees. Nice job. And I did all of that using the properties of triangles within the kite. Nice job. In the trapezoids here. Number 4. Find the measure of angle J in trapezoid JKLM. So if I look here, this is an isosceles trapezoid. Isosceles meaning that the sides are congruent. Okay. So if angle L is 124, what's angle K going to be? 124. Which means what's angle J going to be then? 56 degrees. How'd you find that, Drew? Yep, 180 minus 124. Same side interior angles. Up to 180. Nice job. Next one, number 5. In trapezoid EFGH, FH is 9. So this is 9 right here. That's 9. FH, oh sorry, I want to find AG. Oops, different color. I want to find AG. What do I know about the diagonals of an isosceles trapezoid? They are the same. So what would I do to find AG here? Ken Frost? Yep. 9 minus 6.2, and what do I get, Frost? 2.8. Nice job. All the same. Good work. Take a couple seconds. Try number 6, 7, and 8. A, B, C, D is a kite. Use the figure to find each measure. All right, here we go. Moment of truth. Austin, what did you have for number 6? It is 118 degrees. Yeah, these are the angles that are the same. So angle D is 118 degrees. AB, Johnny, what do you say AB is? Yeah, 3.25. And Mr. Gabe, what do you say about CD? It is 6. Look at you guys, 3 for 3. Nice job. It's okay. That is correct. Nice job. Last ones of the kites here. In kite ABCD, measure of angle BAC is 35 degrees. So BAC is 35. So that angle right there, 35. And the measure of angle BCD is 44. Find the measure of angle ABD, DCA, and ABC. Take a couple seconds, try those. Let's go through these. Measure of angle ABD. What's the measure of angle ABD going to be, Tina? ABD.
Oh gosh, darn, I didn't find ABD. I found EAC.
ABD, what's it, Camden? 55 degrees. Nice job, sir. There is a right triangle right there that you can use to find ABD. What about the angle of DCA? DCA is going to be what, Mr.
22.
It's how many degrees?
22.
It is 22 degrees.
Oh, that's why I just can't be right.
Nice. 22 degrees. Nice job, because you cut it in half, right? And then the last but not least, the measure of angle ABC. What would the measure of angle ABC be? This whole angle right here is a measure of how many degrees, Tom?
Oh, I got this one.
I got
123.
123 degrees.
I was looking at.
Because you have to use the triangle. Johnny, don't double it. These are angle bisectors. The other ones are not. They're not all angle bisectors. It's all right. I understand. Next set of problems here. Oh, just kidding. If they come up. There we go. In a trapezoid. Okay, now we look at trapezoids. Find the measure of angle Z, and then find the distance of ln. Take a couple seconds to try these two problems. All right, number 12 here. Measure of angle Z is how many degrees? Tyler, what do you say? 98 degrees. Nice job, sir. And the distance from for ln. So Z was 98 degrees. The distance for ln, I want to find this distance right here. What's that distance going to be, Anna?
4.9.
4.9. Nice job. How'd you get that? You just
Subtracted 7.5.
subtracted. Good work. All right, last thing we're going to talk about today is the trapezoid midsegment theorem. Okay? The mid-segment of a trapezoid is a segment whose endpoints are the midpoints of the legs. When you think of mid-segment, what do you think of? You think of the middle. Okay, you think of the middle. If I were to give you two numbers, and I said, hey, find the middle of these two numbers, what would you do? Add them up and divide by?
2.
Hey, guess what? That's all it is for the mid-segment. Okay? The mid-segment of a trapezoid is nothing more than you add the two bases and then divide by 2. Okay? That is the distance then of the mid-segment. All right? Anytime you see middle, that's pretty much what you're thinking of here. And that's what we're going to do. Number 14. It says find the value of n so that PQRS is isosceles. Yes, sir. Yes. The top and the bottom. Number 14. Find the value of n so that PQRS is isosceles. If this is isosceles, what do you know about angles R and angles Q? They would be the same. So what would you do to solve for n? Set them equal to each other. 10n plus 19 equals 12n minus 4. And you would solve for n. So I subtract 10n. Add 4. 23 equals 2n, which means n comes out to be 11.5. And then there's number 15. Find the value of z so that ABCD is isosceles. Well, if AC equals 2z plus 9 and BD equals 4z minus 3, what do I know about the diagonals of an isosceles trapezoid? They are the
Same.
So what would I do here? I set them.
Equal to.
Nice job. 2z plus 9 equals 4z minus 3.
Why do you have to use Z's? Do you know how complicated it is to like tell the difference between Z's and 2's?
That's why I put a line to it.
I put a line through my z, see?
I know, but I don't always put a line through my Z's, only during math.
Thanks, Johnny. What's the answer, Johnny? Z equals 6. Good work.
Wait, so we, never mind. For like number 1, we just have to find the value and plug it in now.
And then the last thing, number 16 here. I want to find each length. I want to find KL. So if I look at this trapezoid, KL is where? Right in the middle. So if I look at KL, what would I do to find the distance for KL, Camden? 26 plus 16, and then divide by 2. And the distance for KL is what then, Camden? 21. Now, a couple things here. Listen up, please. When you look at this, you think of mid-segments in the what? It's in the middle. Middle means equal distance from both sides, right? Or like equal distance, right? So what's the difference from 16 to 21? That has a distance or difference of 5. What's my difference from 21 to 26? They're the same, right? Okay, middle. Because what happens if I have the next problem here? Well, I see my distance here is 2. So I add 2, as Johnny said. The PQ then has to be 9.5. I can think of some of those problems a lot easier than using formulas because I know they have to be the same distance on both sides, right? Good work. Try the next 2. Try these 2. All right, number 18 here. What is the distance for EF? What's the length of EF going to be, Caitlin? 9.15. Nice job. And WX. What is the length for WX going to be? Noah? What?
10.8.
10.8.
And Troy got the first one wrong. I multiplied it by 2.
Nice job, sir. Good work.
I multiplied it.
Here is your assignment.
You should just give us